Hello students. In this video we'll see an example of computing conditional probabilities using Bayes' theorem. Let's suppose we have 5 coins and we have that the ith coin has probability I over 5 of landing on heads. Find the probability that the third coin was selected given that a heads was flipped. So in this problem what we have is we have 5 coins. We'll call this coin number 1, coin number 2, coin number 3, coin number 4, and coin number 5. There's 1/5 probability of landing heads from coin 1, 2/5 from landing coin 2, 3/5 from coin 3, 4/5 from coin 4, and 5/5 or 1 from coin 5, which means that coin 5 is a double-sided head coin. So what we are after is we want the probability that the third coin was selected given that we had a head. And so now what we can do is we can say, well, the probability, so let's call this event the third event, and then let's call this event h. We know that this is equal to the probability of 3 and h over the probability of h. And if we flip these roles, we know the probability of h given 3 is also the probability of h and 3 over the probability of 3. Now, we happen to know that the probability of h given 3 is 3/5. 3/5 is the probability of the third coin that you get a head given that the third coin was selected. So 3/5 has to be equal to the probability of heads and 3 divided by the probability of the third coin being selected. Now there's a total of 5 choices over here. So there are 5 equal choices of coin. So the probability of drawing a 3 is 1/5. And so if I multiply both sides by 1/5, we can conclude from this that the probability of h and 3 will be 3/5 times 1/5 from this denominator over here. And so we get a total of 3 over 25. And so now we can fill in what this expression is over here. That expression in the numerator is 3 over 25. And now we need the probability of heads. Well, we can decompose the probability of heads as the probability of heads given 1 times the probability of 1, all the way down to the probability of heads given 5 times the probability of 5. Now selecting the probability of heads given the probability of 1, the probability of 2, the probability of 5 are all equal to 1/5, so we can pull 1/5 out of everything. And the probability of heads given 1 is 1/5, 1/5, plus 2/5, plus 3/5, plus 4/5, plus 5/5. So we have a total of 9, 12, and 3 is 15. So this is going to be 3 over 5 is the probability of heads. So this denominator over here is 3 over 5. And so what we see is we see the probability of the third coin being selected, so the probability of 3, given that heads was selected, is going to be 3 over 25 over 3 over 5. And so that will be 5 over 25 or 1/5. So in this problem, we use Bayes' result, and we use this Bayes decomposition of the probability of heads to compute the desired probability. Thank you very much.